in this question, we're told when Connor rings Ciara's house, the probability that Ciara answers the phone is 1 out of 5. Connor rings Ciara's house once every day for 7 consecutive days. Find the probability that she will answer the phone on the 2nd, 4th, and 6th days, but not on the other days. Okay, so in this question, we're told the probability of success is 1 out of 5. So that means the probability of failure is 4 out of 5. So we're told then that the probability that you'll answer the phone on the 2nd, 4th, and 6th days. Okay, so that means on the first day, doesn't answer, so that's fail. Okay, and the second day then that she answers, so that would be success. Then on the third day, doesn't answer, so that's fail. Fourth then, success. Fifth, fail again. Sixth, success. And seventh, fail again. Okay, so now let's put it in our probabilities. So I'll have 4 out of 5, then 1 out of 5, 4 out of 5, 1 out of 5, 4 out of 5, 1 out of 5, and then 4 out of 5. And then we will multiply all of these. So multiplying all of these gets us 256 out of 78,125. Okay, next question then. So we need to find the probability that you will answer the phone for the 4th time on the 7th day. Okay, so this is going to be a LCHL question. And so if it's the 4th time on the 7th day, that means out of the first 6 days, she's answered the phone 3 times. So out of the first 6 days, so I'm going to have 6, choose 3. So then the probability of success is 1 out of 5. The power of 3, that'll be my R value. Then the probability of failure will be 4 out of 5. So 6 minus 3 is 3, so that'll be to the power of 3. So this is the probability that out of the first 6 days, she answers the phone 3 times. So then let's multiply then by the probability of success on the 7th day, so which will be 1 out of 5. Okay, let's put this into the calculator now. And that gets us 256 all out of 15,625. Okay, so next question then. So Connor rings her house at once every day for n days. Right, in terms of n, the probability that Ciara will answer the phone at least once. Okay, so we know we have the probability of success. Okay, I'm just going to write it again. So the probability of success is 1 out of 5. And the probability of failure is 4 out of 5. Okay, so seeing as he rings every day for n days, and we want to know the probability that Ciara will answer the phone at least once, I'm going to take the probability of failure away from 1. Because remember, in probability, 1 is what it has to happen. So if I take the probability of failure away from 1, that will mean that she will answer the phone at least once. So I have 1 minus now 4 out of 5, but it's out of n days, so it will be 1 minus 4 out of 5 to the power of n. Okay, and that's that part of it done. Now the last part, so we need to find the minimum value of n for which the probability that Ciara will answer the phone at least once is greater than 99%. Okay, so I'm going to have 1 minus 4 out of 5, power of n, greater than now than 99%. So for 99%, I'm going to change that to a decimal, so that'll be 0.99. Okay, so let's try and solve this now for n. All right, so the first thing I'm going to do is I'm going to bring this over here, this over here. So that means I'll have 1 minus 0.99, then 4 over 5 to the power of n. So I'm just want to keep my power of n positive, okay? So it just makes the question a bit easier. So now I have 0.01 is greater than 4 over 5 to the power of n. Now, seeing as I'm looking for a power, let me take the ln of both sides. So from your rules of logs now, the n will come down. So now I have ln 0.01 is greater than n times ln 4 to the 5. So now I'm going to divide both sides by ln 4 over 5. So I'll have ln 0.01 divided by ln 4 over 5 is greater than n. Okay, putting that into the calculator then gets us 20.637 greater than n. And now we're told we need to find the minimum value for n, for which the probability that Kira will answer the phone is at least greater than 99%. And seeing as it's 20.6, I will have to have it as a whole number. My answer will be 21. So n will be equal to 21, because if I round it down to 20, okay, it wouldn't be greater than 99%. And if we want to check that as well, we can. So if we have, go back to our original equations for 1 minus 4 over 5n greater than 0.99. If, let's say, I put in 20, I'd have 1 minus 4 over 5 to the power of 20. And putting that into the calculator will be equal to 0.98. Sorry, 8. So you can see that that is less than 99%, so it cannot be that. However, if I do 1 minus 4 over 5 to the power of 21, then that is 0.99077. So greater than 99%. So we can see that 21 is the correct answer. Okay, and that's the question done.